Our planet is constantly changing. We might not always feel it, but beneath our feet, the Earth is in motion. This movement happens because the Earth's outer layer is broken into large pieces called tectonic plates. These plates fit together like a giant puzzle, but they don't stay still. They constantly push, pull, and grind against each other. The boundaries where these plates meet are called faults. Faults are fractures in the Earth's crust where rocks have moved past each other. Imagine cracking a piece of bread but not breaking it completely in half. That's similar to what a fault looks like. These cracks in the Earth's crust are incredibly important. They tell a story of our planet's dynamic history, a history filled with incredible forces that have shaped the world we know today. The Earth's tectonic plates are constantly moving, but this movement isn't always smooth. As these plates push, pull, and slide past each other, they create immense pressure and stress on the rocks at their boundaries. Think of bending a twig. At first it bends and flexes, but eventually, if you keep applying pressure, it snaps. The same principle applies to rocks. When the stress on the rocks becomes too great, they fracture, creating a fault. The formation of a fault is a dramatic event, often accompanied by earthquakes. These earthquakes release the built-up energy in the form of seismic waves, shaking the ground and sometimes causing widespread destruction. Not all faults are created equal. Just like there are different ways to crack a piece of bread, there are different types of faults, each formed by a different type of plate movement, normal faults. These faults occur when rocks are pulled apart by tension. Imagine stretching a rubber band. Eventually it will snap, creating two separate pieces. Reverse faults. Reverse faults form when rocks are pushed together by compression. Think of pushing two sides of a tablecloth together. The fabric will buckle and fold. Strike-slip faults. These faults occur when rocks slide horizontally past each other. Imagine placing your hands flat on a table and then moving one hand forward and the other backward. Each type of fault creates distinct landforms and is associated with different types of seismic activity. Understanding the different types of faults helps geologists better understand the forces shaping our planet. The movement along faults is the primary cause of earthquakes. When rocks along a fault suddenly slip past each other, they release a tremendous amount of energy in the form of seismic waves. These waves travel through the Earth, causing the ground to shake. The point beneath the Earth's surface where the rupture occurs is called the hypocenter. The point on the Earth's surface directly above the hypocenter is called the epicenter. Earthquakes are often most intense at the epicenter, but their effects can be felt for hundreds or even thousands of kilometers away. The strength of an earthquake depends on the amount of energy released during the fault rupture. Larger faults can produce much larger earthquakes. Understanding the relationship between faults and earthquakes is crucial for predicting and mitigating the risks associated with these natural disasters.